Welcome, everyone. Hope you had a great lunch, that you're enjoying the conference so far. Thank you all for coming to this session about what's new in C#, what's happened with C# over the past decade or so. There's a lot of stuff that we're going to cover here today. Before we do that, could we, as loud as we can, give the organizers a round of applause? Thank you. Everyone else is going to be very confused and think I just finished in under a minute. There's nothing new in C#. I'm kidding. My name is Filip Ekberg. I'm super happy to be back here. After this, if you have any questions, feel free to send me an email. Over the past 10 or 15 years, I've told people to send me emails, never got any emails. I thought I was super crystal clear in everything I talked about. Turns out, I didn't have my email on the slide. Bad mistake. So now I'm going to get a handful of emails about everything in regards to C# and .NET. Oh, okay, so we're going to talk about everything that's happened to C# over the past, let's say, since C# 8, 9, 10, 11, 12, 13, and also what's going to come in 14. This language has changed quite a lot. There's additions to the language that let us build applications that perform better, applications that are more robust in terms of less exceptions, and also reduce the amount of code that we have to write, so it's easier to maintain as well. Some of these language changes, such as generics, async and await, and pattern matching, all kind of fundamentally change how we build our applications, how we describe our code to make it easier for anyone that's working on our applications to follow along and to participate. So let's go through a couple of these really interesting features across this talk here today. Now, if you haven't kept up, we're at .NET 9. This is the latest version of .NET. Who in here is waiting for an LTS version before they upgrade? Most of you don't dare to say. Half of you. All right, so there's really no reason whatsoever to wait for an LTS version. And I'm sorry, I'm not calling you out that you're not upgrading, but an LTS version simply means that it's the long-term support version of .NET. .NET 10 is going to be an LTS version, but you don't have to wait to upgrade. If you upgrade earlier, you're going to get access to all the language features of C#, every performance improvement in .NET, and by no means is an STS or a short-term support version in any way less performant, or it's not experimental feature or anything like that. It's just as robust as the long-term support version. The only difference is that Microsoft supports the other version a little bit longer. So if you haven't already, go ahead and upgrade to .NET 9, and you'll be able to use everything that we're going to talk about here today. One of the language features that have been quite drastically changed over the past few decades, or something that's really a mistake to introduce in the first place, is something that leads to a little bit of a problem like this here. Anyone in here that's ever seen this before? Like, most of you are liars because you don't raise your hands. Everyone has probably seen this problem. Nullable reference exceptions, or problems with objects not being set to an instance. Now, the alternative is, of course, to always ensure that we have an instance of an object, ensuring that we set something to a default value, which is tricky. So using nulls is sometimes just the easy way of solving this. But there's a little bit of a problem here, right? Because we don't want to end up having applications that crashes. So the solution is for the compiler to tell us that there could be a potential problem. And this has been made by introducing what's known as nullable reference types. This was introduced in C# 8, and the reason I talk about this now, when I promised to only talk about C# 9 and onwards, is because they continuously improve upon this feature. They add things in C# to complete this language feature to make it easier for us to avoid null reference exceptions. So let's jump over to Visual Studio, and I'll show you a couple of examples. Let's head over to a little bit of a project where I've turned on nullable reference types. And we do this by going into the csproj file, and we have nullable enable. And if we have this enabled, you'll see here that we get a couple of warnings. It's telling us that this here is not set to anything. This could potentially be null. And the reason the compiler is telling us this is because it now thinks that every reference type, like a string and an object, they should all be set to an instance. However, the compiler cannot determine that this has been made. So how do we fix this? Well, we can either ensure that we've set this to a value and the warning goes away. But I don't really like this approach. We could also introduce a constructor, which would then be in charge of setting this to an instance. But instead, I want to have this class to ensure me that I've set this to an instance when someone creates an instance of it. And the way that we do this is to introduce a feature called required. If I do this, it's going to move that error away to somewhere else. So the compiler now knows that whenever you create an instance of this details class, you're required to set this to an instance. Therefore, it will know that this is not going to cause a null reference exception. I can also use this together with another language feature called init only. Now what I've said here is that I've said that you're required to set this to an instance, and you're only allowed to do this once. So effectively, it's an immutable type. Still have the problem with the last name here, and I could say that, well, I'm going to set the last name to be optional. And we do this the same way we've done forever in C# since they introduced nullable value types, by using a question mark. Now what happens here is that the warnings are disappeared from this class here. They're going to be apparent somewhere else. I'm going to do the same thing for this person class here, which is a reference to the details. I'm going to say that this here is required to be specified. So where is now the problem, right? Because the nullable reference exception would probably not have been happening inside that details class anyways. Instead, if I expand this here, we can see that this is where that potential exception would have occurred if someone didn't set this to an instance. So now the compiler is telling me that you should probably null check this property, because it's optional. So with nullable reference types enabled, and the compiler knowing that everything should be set to an instance, we can now find these places that could potentially cause issues when we run this. And of course, we can be very certain that we try to set this to an instance everywhere, but if we're deserializing data coming in from JSON, then we might not actually have this set to an instance. So what we do here is that we can say that I'm going to use the null conditional operator to say that, hey, there's a default value here. 9 is probably a very bad default value. Let's do 0. I can do that, which is quite nice. So now I added a check here to ensure that this is not null before I proceed to access a parameter. The compiler is super smart, though. It will use something called the null state static analysis to know that I've null checked this before accessing the variable. So I can do argument, null exception, throw if null or whitespace, person.details.last name. So now what happens is that it will ensure that we're not going to get to the next line, and the compiler will know that this method has appropriately null checked this property, which is quite nice. So if I do this with a normal if statement, if I pass it into a method that promises that it performs a null check, I don't have to add this myself. So this here will now tell us that we should do something about fixing this code. And we can use this in other places as well. So for example, I have a method here that returns an IEnumerable of person, and there's nothing wrong with this method signature. But if I expand the body here, we can see that, well, I'm returning null, which is probably a really bad idea. There's also this thing called a dammit operator, where I know better than the compiler. I'm going to say, damn it, this is set to an instance. We can clearly see that that's not really the case here. So this could, again, throw an exception if used incorrectly. But prior to the required keyword, using the dammit operator, or null forgiving operator, which is a more boring name for it, this was the way of avoiding that warning. So if you're stuck in an older version of C# and .NET and you want to bypass this warning, you just do an exclamation mark, and it sort of works. It would be better, though, if I just returned an actual value. Or if I really want to return null, I can say, like, hey, this is optional, but then the consumer of this method has to ensure that they do a null check and so forth. This is just a way to move that warning to somewhere else. So now, if we do this appropriately, we can say, well, I want to yield return, because I don't want to create a new temporary list. I want to create a new something. And then inside this something, I'm going to create a details, set that to another new something. And if we just do this first, there's a couple of cool things here. I'm using what's known as a target type new expression. I don't have to explicitly say that I'm creating a new person here. The yield keyword will create a temporary list. I don't have to create a new list and return that for me. This is just setting up an iterator. The target type new expression will check that I know that you're going to create a person, so therefore explicitly defining person here is kind of unnecessary. Same goes for details here. But I have a compiler error, even though I'm using this thing here. I'm going to set this to an instance. If we zoom in here a little bit, if that will work, let's see here. There we go. It's going to say that the required member first name must be set. Otherwise, we can't proceed. And this is a C# 10 feature. So I'm going to say here that first name is in fact set to a value, and now I've ensured that this has been set to an instance. Hopefully I don't get any null reference exceptions from this. And of course, if we write bad code and we trick the compiler into thinking things have been set to an instance, we'll still end up having problems. So we should probably try to avoid that. And going forward, there's going to be more improvement to this as well. C#14 is going to introduce null conditional assignment. So even though this language feature that works on avoiding null reference exceptions was introduced for quite a few versions ago, it's still being worked on, still being improved. All right. Let's see here. Come on, here we go. So that's a nullable reference types. Now, a really great thing to also enable when we do this is to turn on a flag called treat warnings as errors. So how many of you are actually looking at all your warnings, ensuring that they are all not there? Fixing all your warnings. Again, I see a bunch of liars. Actually, the audience that probably are the most truthful, because most of you didn't raise their hands, because no one looks at their warnings. But if we turn this on, I bet that people will fix the problems. So what happens here is that once we compile the application, all the warnings will be treated as errors. Doing this on an old application is probably not the best idea, because there's going to be a million warnings. Or you do it and you go on a holiday, and someone else fixes the problem. Probably not a good idea. But it's good to do in new applications. Like if you start a new project, turn this on. It's a very nice way to keep your application tidy, or the code base tidy. Now, C#9, if we're going to talk more specifically about what was introduced in C#9, that introduces the concept of a record type, a new way of creating a reference type. Really just a class behind the scenes. It introduces that concept of an init-only setter to allow us to do immutable properties. Top-level statements, it introduces pattern matching enhancements, there's target type new expressions that I just showed you, and a bunch of different things, all targeted towards lower-level stuff or more performance stuff or things that they need internally at Microsoft or in the .NET teams. So being the 9th iteration of the language, there's quite a few things here that they improved upon. One specific thing that I want to talk a little bit more about, we've looked at the init-only setter and the top-level statement. The top-level statement is this thing, which allows us to write a program file without doing the public static void main stuff. We can just do a very simple, slick program.cs and start writing our code in this. It implicitly it just introduces, it imports things like link and so forth automatically. We don't have to do that ourselves. So it's quite nice. This is used for minimal APIs if you're doing ASP.NET Core. So one thing I want to talk a little bit more about is the pattern matching. And come on. Let's try that again. All right. Buy a Mac, they said. Everything works great on a Mac. I'm just joking. It's never really been a problem. So pattern matching is a way for us to look at certain things. Like in this case here, I can determine what an object is, like what kind of shape or form or colors and so forth. It's a language feature that's been around for a long time in other programming languages. And basically, it allows us to match on an attribute or a type. Let's say that in C#1 through 6, we were able to check if the type of the fruit is an apple, and we can check a different property. And then we have to typecast that into the appropriate type to use that inside. It works. Like most of us probably write code like this still. It's not the best way to do this, though. Like we have multiple different ways of achieving the same thing. Like if we were to do this with a switch statement instead, we can do something like this, pass the instance into the switch, and that would work as well. We can use a case here to check what the type is, and we can check property values. Don't have to do any typecasting. However, and also use the default case here as well if we wanted to. However, this can probably be improved upon, and in C# 8, 9, 10, 11, 12, 13, 14, this has been improved upon again, like any of the other language features. They've introduced the switch expression, which allows us to look a little bit differently at how we can produce expressions for different types, to check what the content is, what the type is, certain different property values, and so forth. That's the object that I want to create a pattern for. So I want to produce a result. based on this object. And I'm going to fill this with expressions, basically, as well as patterns. An example of this would be to say, like, hey, what kind of fruit is this? I want to get the text representation of what this fruit is. If it's an apple, I'm going to return this thing here from it, the string here. This could be a method call that produces some complex type. You could do whatever you want, basically. This allows us to write a little bit more complex code that reads more easy. It's easier on the eyes. It's easier to maintain. But again, as with any other language feature, if we use this incorrectly, the code will end up being unreadable. I can probably show an example of that soon, as most of my code. So patterns in C#. There's quite a lot of different patterns that we can introduce. You just saw the type pattern. That's a very simple way of saying, hey, is this the type that I'm looking for? We can check positional patterns used when we deconstruct an object, probably a little bit less frequently used. We can check the property values. We can check values inside a tuple or tuple. We can check the value of a particular field or property on a type, and they create a relational pattern for that. We can create a conjunctive AND pattern, say like, hey, this value has to be more than 10 and less than 20, for example, which is very, very convenient. You can also exclude values by using the disjunctive OR pattern. There's a list pattern. Parenthesize pattern can negate things like saying, hey, if it's not null, don't worry, you don't have to remember all of this. I'm going to show you a couple of these examples as well. We also, if we use more than one pattern, it will first check the first pattern, of course. Like if it's a type, it will do that, and then recursively check the property value, and then recursively check whatever else you're checking, right? So let's jump over to Visual Studio again. I have a quite simple application that has a couple of records defined. So a record type, before we check the pattern matching stuff, this class or these classes are really just generated code, basically. So I'm going to do abstract record, which is really just a record class. A record is a new reference type, where it really just generates code for us. And the easiest way to show this is to compile the application and jumping over to something like ILSpy to show you that what happens here is that the class test result, abstract class test result, abstract record test result. This primary constructor defines a couple of backing fields, a couple of publicly exposed properties, and it also ensures that it implements IEquatable. So a record is a very concise way of producing a class that implements IEquatable and gives us value-based equality, gives us an immutable type. It's a quite nice way of producing types. And checking here, we can see that we have a backing field called number of attempts. If we check the class here, we have publicly exposed property, has a backing field. It's quite a lot of things generated in here. But if I scroll down, one of the interesting implementations here is that it overrides equals. It will first check the reference if they're the same. That's probably the most cheap way of checking if two objects are the same. But then it checks the backing fields. So it will compare number of attempts with the other number of attempts in this case here. So if I have two instances of this test result, if I compare them, it will compare the property values or the values of these different fields. And of course, since there are all classes behind the scenes here, I can do inheritance. So it inherits from that public, from that record. And at the top here, you also see a file scope namespace. So I don't have to wrap my entire class or records inside a namespace declaration. All right, so if I use this, I'm going to go into my program. I'm going to call a method called getTest, which simply returns a test result. Expanding this shows me that I'm going to create a new failed test. If I want to change a value, now I'm going to get rid of that for just a second. If I want to change the value of, let's say, number of attempts to 4, I'm not allowed to do that because this here is immutable. So I'm not allowed to change this value. And immutability is important in multi-threaded applications. And I do want to say, though, that because this is using value-based equality, you're not able to use this with Entity Framework. You can use it for anything else, like all your DTOs and your models and so forth. You can use records, but just not for Entity Framework, because it relies on reference-based equality checks. So if I want to create a new version of this test result with a changed number of tests, I have to use another approach here. I have to create a new instance. I could dereference this to say, hey, I'd like to get test is equal to test with a changed value. And this with expression here allows me to now get a new instance and dereference the first one with this newly created one. And again, in multi-threaded applications, this is really important because now I haven't changed anything. I'm not going to run into any race conditions. Still a million things that can go wrong in a multi-threaded application, but at least we're avoiding the race condition portions, hopefully. All right, so that's the record types and how we use them. Now, to apply some pattern matching here, I'm going to retrieve the abstract class here. Like, we know that this is going to create the failed test, but I don't know that here. So what I want to do now is do var result is equal to, based on the test result, I'm going to produce a switch expression and say that, hey, if this is failed, I'm going to return the text failed. If it's passed, and it has a number of attempts less than 10, you've passed. Okay? For everything else, you failed. So this here allows me to create quite complex patterns. Now, this doesn't look very complex, but what I can say here, like, well, it might be passed, but I've actually not performed the test yet. For some reason, there's a bug. So I can also say, like, well, it also has to be more than 0 and less than 10. Now, as I said earlier, like, we can write really complex patterns. And I can also negate this entire thing. I dare anyone in here to tell me what this is doing now. It's probably just checking if it's null or not, right? Because basically, when you have a type pattern, it's going to ensure that it's an instance of that, so it cannot be null. So it's going to say, well, if this is an instance, this passed. Super confusing. So let's not use not. Use that only for not null, basically. I can also capture this using a declaration pattern, say like, hey, I'd like to get the pass test. Now I've declared that as a local variable that I can use inside my expression. Let's see here. I could do pass dot number of attempts, for example. And this is actually, if we tidy this up a little bit here, this is the correct type. You don't have to do any casting yourself, like it's all captured as the appropriate type inside this expression, which is quite nice. We can also use this not only for switch expressions, but this is applicable to if statements as well. So for example, if we were to do if get test is passed, we're going to go into this little block of code here. Like, they don't have to be super complex, right? So this is checking that it's not null, checking that it's the appropriate type, but we can also, again, check that it has some specific property values. For example, number of attempts, more than 1. Super convenient language feature that's been around for a long time in other programming languages. And C# has picked up, and there's a lot more patterns that we can add as well. Again, I do want to say, don't apply the not pattern here, because that's going to make it all very confusing. And one thing more I want to show you here at the top, you see the global keyword in front of the using? That means that nowhere else in my entire project do I have to add using NDC, for example. It's going to be globally available inside that namespace. It's nice for Blazor applications and Maui applications and so forth, where you might have to do usings inside the eraser files. All right. And there's a couple of more patterns that we're going to talk a little bit more about. But before we do that, I want to talk a little bit more about C#. Specifically C#10. Here we go. So C#10 improves upon the records. They add record structs, a little bit different to record classes. They're not immutable by default. You'd have to say read-only record struct, which is super confusing. But basically, just different ways of storing the classes. It's value-based versus reference-based. It improves structure types. There's the global using directive that I just showed you. The file scope namespace is also from C#10. They extended property patterns so that if you, for example, if you were to, in my case, prior to this, if you were to say, hey, I'd like to get the number of attempts and the length to, let's see here, let's do not number of attempts. Let's do test date dot year has to be more than 2015, for example. Prior to C#10, if we did this, this could throw a null reference exception because it didn't ensure that it wasn't null. What it's actually doing now is to say it unwraps from this. Test date has to be a nested pattern where year is this. This is what you'd have to do in the past, which is not looking as nice. So in C#10, they improved upon this. So when you do a dot, this will perform a null check as well. And this kind of gives you a hint that the curly brackets is actually ensuring that we have an instance. So we could do if test, if I can type test result is an object. That's another way of doing a null check. Not sure I recommend anyone doing this, because again, I think this reads better as a comparison. All right, that's a tangent. Okay, and they improved the Lambda expressions, constant interpreted strings, and there's a couple of more things in C#10 as well. Some of them less important than others. One of the most important ones is probably, or one of my favorite ones, is probably inferring the delegate types in lambdas. So this is in C#9, you'd have to say explicitly which type of delegate that you're expecting, even though we can clearly see that the lambda produces an input of a string and an output of an integer. With C#10, it simply infers that. Letting the compiler do most of the work for us is a good idea because it's going to do the smart decisions, and it can then also produce the appropriate types that's mostly performant. Like if they add something in .NET 15 that's much more convenient for it to use, but by just recompiling the application, it could potentially be a little bit more performant. This here is an example of a minimal API, which is something that's possible due to the top-level statements, the file scope namespaces, the global using directives, and all the Lambda improvements. And now also allowing attributes in Lambdas allows us to write really powerful APIs. This here is pretty much all there is in a program.cs file to produce an endpoint that listens for /ID on an HTTP call. But without being able to do from header or from body or whatever we'd like to add as an attribute, then the minimal APIs, they aren't really fully functional, like in comparison to a traditional MVC project. But nowadays, it's a little bit of a, I think most people would prefer writing code like this here because it's much easier to maintain smaller portions of APIs, especially if you're doing microservices. So if we head over to C#11, we got more patterns. They, again, build upon these language features that were introduced in earlier versions. They're adding a list pattern, a slice pattern, a span pattern, and of course, I'm going to show these as well. There's a name of operator, and performance-wise, they're caching delegates for static method groups, which was, for a long time, if you ran into this performance issue, it was a little bit annoying that it just didn't do this by default. Some of these compiler improvements are probably not super easy to implement, but once they've done it, and there's a huge performance boost by just recompiling the application, I think that's quite nice. The required keyword came out in C#11. I showed you this earlier when talking about the nullable reference types, and it took quite a few versions, right? So 3 versions after they introduced the nullable reference types, only then did we get the required keyword. It can be a little bit tricky to keep out with which version goes with which .NET, which is, again, why you should always keep to the latest version of .NET. But you can also, and I should probably show you this right away before I forget. If you go into your CS project file, let's assume that you're stuck in .NET 6, or anyone using .NET Framework? Oh, wow. There's like a handful. Amazing. What you should do, you should go into your CS prod file and do lang version preview. That will get, if you just have Visual Studio 2022 installed, and you have, let's say, the Visual Studio, the preview version installed or whatnot, this will give you access to all the current features of C#, as well as all the preview features of C#. And by just doing this, you'll be able to access all of those different language features. If you don't do it, like if you're not using the features, it won't have an impact. It will just use the latest version of the compiler, which is a lot better. Now, I said earlier that you can email me if you have any problems. Don't, if you don't have any problems with that. I'm just kidding. It's an unsupported feature. So if anyone from Microsoft, if you ask anyone from Microsoft, they probably don't support that. But there's a lot of source generators that you can use if there's missing things, if you're using .NET Framework and you turn on the latest version of C#. I showed you a couple of interesting features, such as the target type new expression, and there's a lot more that we can build upon as well. But if you don't want to access most of these different things, like pattern matching, that's just compiler magic that would compile down to compatible IL. So if you're working in older versions of .NET, try to just change the language version and see what you can use. One of those language features that is really amazing is the required keyword. And this is also something that's reflected inside system.text.json. If you use that, it will try to enforce that you're actually doing this and you're setting something in the JSON when deserializing the data. So it will look at what your classes are annotated with. There's this concept of a raw string literal. There's static abstract members and interfaces, UTF-8 string literals, so that I can say, for example, in this case, that I'm going to take my string Filip Ekberg, and then I'm going to look at this as a UTF-8 string in memory, which is basically just converted into a byte array. I'm using a read-only span because that is a more performant way of representing our arrays. It's not just in terms of performance when I'm just pointing to the array and accessing all the elements, but it's when I'm doing manipulations, slicing off portions. The spans are a really great way of representing any arbitrary type of memory. And the reason we want to enable UTF-8 support for strings is because they're UTF-16 by default. Data coming in from the web is traditionally UTF-8, so if you have to convert that UTF-16 data into UTF-8 all the time, again, you're going to get a performance hit. A lot of the language features coming into .NET and C# is all about performance, making applications more robust, and making it easier for us to develop. There's generic math support, there's generic attributes. For the longest time, I wondered why this wasn't available, especially when I did ASP.NET, traditional ASP.NET, with web APIs and so forth. But now that's available. What's interesting with C# is that it's open source. And if you've kept up, there's this language feature that was called parameter null checking. Due to community feedback, they actually withdrew this language feature, and I'm going to show you why I think that is. So imagine that I have to say, like, well, if this is null, I'm going to throw new exception, like that. Or it would be more appropriate to say argument null exception, probably. So instead of having to write this for all our different arguments, it would be better if there was a way for the compiler to do this for us. So the language team, they implemented this feature. You just do double bangs, like double dammit, and it did that by default. So it would just introduce the code for you, which is quite intrusive. Like, it generates code that performs a null check and throws an exception. The problem is that eventually, with all the question marks and exclamation marks, C# will eventually look quite terrible. Like, you'll end up having code that looks like this. Like, I don't really like this, which is also what the community, like, it's not going to end up looking that like. You get the idea, right? The community didn't like this, and being open source, like, I'm saying this because if there's something that's coming in C# and you want to participate in the discussions around why that is, or it's like, I don't think this fits into the language, you can go ahead and you can give your comments and tell them that this is not a good idea. Funny thing is, also in relation to why you shouldn't use preview features of the compiler, when they introduced this, they built the feature in the compiler, they deploy them in their nightly builds. All the .NET teams and the language teams use this for all their projects, all the open source projects. Whole of GitHub was refactoring to using exclamation marks all over the place, and then they removed it. Imagine people were upset. Which is why you probably should stay away from preview things before they're actually released in the language. So as you see here, C#11 had quite a lot of interesting features added to it. I'd like to actually go back to Visual Studio again and talk a little bit more about the different patterns they introduced for lists, spans, and slicing, as well as the raw string literals. So let's do that. Let's go over here and check a little bit more patterns. So I have this span of a byte here, and I'm using hexadecimal numbers because it makes me look like a hacker. Doesn't matter. It could be strings, integers, whatnot. Now, what if I want to check if the first element is of a certain value? Well, of course, I could use a normal array accessor and check it. But why not use something like link? The problem here is that this isn't really performant, and it doesn't even work in this case here, because I've changed this to a span. If I change it back to a byte array, I could probably do that, right? But to avoid this, because I don't want that, because this isn't the most performant version, instead, I'm going to use one of the new patterns that's available in C#. I can now say that, well, if the list is an instance of a list, and the first element is 0x1, I don't care about the next one. The third one has to be this, and then it can be followed with whatever. Like, it doesn't matter if it's 0 elements after it. It doesn't matter if this is the last element. It just has to look like that. This discard worked with anything. Say, like, I don't care. It just has to be an element present. It could be null. It could be set to whatever value. We can also say, like, hey, I'd like to check the last element. The last element has to be 0xf2, and I don't care about what the list starts with. Super powerful when we're working with lists of data. Now, in relation to this, we might also say, like, hey, what if this here starts with 0x1, and I'd like to grab everything in the middle? I can do that. So I can now capture or slice off all the elements in the middle of that array. And this is interesting, because now I have a span of byte here, but if I were to change this to a byte array, this here would be less performant. It would have to create a new byte array with that representation, leading to copy of data. Changing this to a span means that I just get a pointer. So spans are basically just pointers to data. And in this case here, I'm just pointing to the middle section of all that data without having to create any extra allocations. So that's the slice pattern. Now, the last one is a span pattern where we have, for example, in this case here, I have my name as a string. This can be implicitly converted into a read-only span of a character. Again, a very memory-efficient way of working with collections of data. Prior to this version of C#, you weren't able to say, like, hey, if that content is the same as this constant string, you weren't able to do that. So now there's a span pattern so that it can implicitly convert back and forth between those supported types. There's also the addition of UTF-8 raw string literals, UTF-8 string literals. So in this case here, again, I've got my name here represented as a read-only span of a byte because I have U8 here at the end. I'm going to find the index of my first name. I'm going to slice off my first name using this syntax here. Slice everything up until the space. Jump over the space and slice the rest of it. Basically, producing a zero allocation way of slicing off data. So in this case here, I don't have to do any extra allocations. Someone is probably going to think, now, well, you're actually allocating a couple of references. Sure, but I'm not copying any new data over. Doing this traditionally with link, for example, or copying the entire string contents is a much more expensive operation. Next, we have the raw string literals, which basically allows us to write XML or JSON inline by using these 3 exclamation marks. We can add our code inside that block here without having to do any escaping, which is quite nice. If you're producing any CSV or any XML or any JSON you're going to return, this is quite nice. All right, let's see here. Let's jump over to this just to reiterate here. Here's a different example of the list pattern. So I have a list of strings here. It's a couple of names. I'm going to use the switch expression to check if it starts with Filip, I'm going to capture all the middle ones as long as it ends with Elise. I can skip the first one and say if the second one is Sophie, I don't care about what follows after that. And then I have one that just checks that it's an instance of a list, but I don't care if it's empty or a lot of elements. And then the last one will check that if it's not an instance of a list. Same as doing null, basically. The raw string literals also work with string interpolation, if you want to do that. It's quite nice. When you've ever found the case of using something like this, it's a nice little language feature that you might not use it all the time, but when you run into the case of having to escape all of these different quote marks, it's quite annoying. So this is a nice addition. And again, I think this is probably one of the more important language features to take away from this. Not the UTF-8 string literals in particular, but the way that we can now use something like the read-only span to, in this case, locate that space using the UTF-8 string literal of a space, and I can slice off data to get a zero allocation piece of code. So this here all produces just new spans, which are basically pointers to different portions of that same data. It's great for scanning huge documents or grabbing portions of a document. And the only place where you would then do an allocation is when you do toString or when you need to write this to somewhere. But given that, for example, there's file extensions. If you need to write this to disk again, you only need to have one representation in memory because most of the types in .NET will now support working with spans and memory of T. So once you've sliced off some data, you can very simply pass that on to somewhere else and write it down to disk without having to perform any extra allocations. It's quite nice. Another improvement is static abstract members and interfaces. Prior to this version, if you had a static on an interface, or in this case on iSingleton, you were never required to actually implement this. But now when you have abstract after static, it will now give you this error saying that, hey, this is not implemented, so you should probably go ahead and do that. Now, the next language version that I want to talk about is C#12, which introduces the concept of a primary constructor, taken from that idea of record types, but it works a little bit differently. It introduces collection expressions and a spread element. I've actually had this in the code, but I haven't really talked about it yet. There's a concept called interceptors, optional parameters and lambdas. There's alias anytype, inline arrays, ref-read-only parameters, and an experimental attribute. So being the 12th iteration of the language, still there's quite a lot to add to it and take inspiration from other programming languages. So let's take a look at this. There's this concept called a collection expression, which will hopefully change the way that you create lists of data. So here, I'm going to create this payload of a span of a byte, and this is the collection expression, having the brackets and following that with elements, instead of having to do new span of byte with these different elements passed into the object initializer. It's not just that, though. Like, it will figure out the target type, and it will produce that without me having to change anything. So if you're passing something into a method, you can let the compiler use the most appropriate overload. By using the collection expressions like this here, it will produce that list for you. Now, I have two different types here. So I have a span of a byte, I have a byte array, like let's just say that this is a list, for example, and I'd like the result to be a span. What I want to do now is to say, like, I'm going to take the payload, and I want to combine that with the checksum. Like, I know how to do this with LINQ very easily, but that would require quite a lot of potentially more CPU and memory. Instead, I can use a collection expression to say that I'd like to take everything from payload and spread that across the beginning of this list. So this is known as the spread element. I can then say I'm going to take the checksum, not HR, checksum. Come on. There we go. And spread that after the payload. I'm not limited to 2 here. I'm not limited to, I can do this. Don't know why you would do that. That would be totally confusing to the consumer of this. But you can do that. You can spread as much as you want across this using the collection expressions. And what it will do is that it will use the collection expression to create the target type you're expecting. So in this case, a span of a byte, which will then create the most appropriate version of that for you. Most memory efficient way, so to say. we also got the concept of a primary constructor. So if you're working in MVC or APIs or, or view models or whatever, probably have a bunch of different repositories and services injected into your classes. This here is a primary constructor. If I were to change this from a class to a record, what happens is that this is publicly exposed. It will then publicly expose the repository to anyone that has an instance of this object. If I change it to a class, the primary constructor will only set this to a private field. It will not be exposed publicly outside of this class. You can still use it inside of this class, like this here. I have a method here that returns a tuple or tuple, and I'm consuming that repository. So very much just like a private field that's set in the constructor, but you don't have to write that boilerplate code yourself. All right. So the collection expressions are a great addition. Very easily allows us to construct new lists of data and also use the spread element or spread operator, I think it's spread element, to spread that across. Primary constructor is probably great for things like a controller, but less so for things like this here. This is just a DTO, right? Adding the primary constructor here is probably not what you'd like. Because if I decompile this and take a look at the source code, we can see that this generates a backing field that is then just set inside the constructor. You'd probably be better off using a record in this case here. And they also added optional parameters in lambdas, again, allowing us to further embrace the idea of using minimal APIs and writing code that more represents what you would actually write for normal, traditional MVC controllers and actions as well. There's also this concept of alias any type. So at the top here, I'm saying like, hey, I'm going to use dimensions, and every time you refer to that, it's going to be a tuple or tuple, depending on how you want to pronounce that. And you can alias anything that you'd like to. In this case, I did a tuple. They also added a concept of interceptors. This is for source generation. So let's consider that we have this piece of code here. In my case here, I haven't implemented log internal, but I'd like to replace this. Let's say that I install a NuGet package that analyzes my code, and it's going to produce a very performant implementation of log internal. That's done by introducing this interceptor. So this method will intercept log internal, and that's a generated piece of code. The implementation looks a little bit different as of .NET 9, and its primary use case is for source generation. But basically, it allows anything to replace anything in your code. So if you install a NuGet package and you say like, hey, I'm allowing you to intercept any of my code, then basically it can intercept whatever we want. This is used a lot in ASP.NET Core, especially when doing ahead-of-time compilation. It's a good language feature if you're doing source generation. All right, so the current version of C#, which is C# 13, doesn't introduce as many groundbreaking features as the prior versions did. They introduced the field keyword, which is up until a couple of weeks before they released it publicly, or released the STS version of .NET. That was not preview. That was supposed to be a part of .NET. But for a couple of reasons, they withdrew that, and it's now a preview feature of C#. I'm going to show you that as well. They introduced params collections, a new lock object, implicit index access, overload resolution priority, and they've done some improvements to partial types. So let me show you a couple of these features. So first off, let's wait with the field. Here's a very simple one. If you're working in multi-threaded applications, you've probably used a sync root, a private static object in your class that you use with a lock keyword. If you simply change that to this lock object instead, this new type in .NET 9, the whole internal implementation of how the locking mechanism works, how this works, will be a lot better. It will no longer use a monitoring-based API internally. It will be better thread synchronization, which is in overall better and hopefully a little bit more performant as well in comparison to the older style. So try just to change your object, like you had this before, to a lock, and then it will just be better, and just recompile the application. Now, when it comes to field, here I have a professor that works in a particular field. I have a public field, I have a public property called field that's going to return this. But as you see here, this is blue, this is highlighted. if I were to go back here and not use a preview version of .NET, what happens here is that this references the backing field. But as I upgrade to, which is actually going to be C# 14, which is going to come in November, this is going to change. Because now, come on, I'm not doing that. Here we go. Now what happens is that field is now a contextual keyword that references the backing field of the auto property. So for example, I can say that I'd like to sanitize the field before I set the backing field to a specific value. Or probably better off doing that when you return it from this, so you always store the raw actual data, so you can recover if there's a problem. But that's beside the point. So this language feature is kind of a breaking change. If you want to access the backing field, you'd have to use the keyword escaping character like this here. Just like async and await, basically. They're contextual keywords. So if you have a backing field called field, you're going to run into problems, which is why they changed this to be a preview feature as of .NET 9. It's going to be not a preview feature in .NET 10. All right? And I would say that it's nice because you can now then sanitize data before you set the backing field or before you return the value. You don't have to introduce the backing field yourself if you don't want to. But I do believe that this is the first time that they've introduced a breaking change in the language like this here, unless someone would have named their variables await or async in the past, right? The problem here is, of course, or the solution is to use the keyword escaping character, if we'd like to. Now, they're also going to introduce something called params collections, which builds on this collection expressions implementation in C#. It works with spans, read-only spans, arrays. It's going to avoid implicit conversions. It will use the spans will take precedence over normal arrays. So it's quite a nice language feature, to be honest. But in this case here, if you are a human compiler, you're probably going to notice that these are ambiguous. Like, if anyone saw that, I'm very impressed. So it won't be able to figure out exactly which one of these it's going to use. And that's why they also introduced another type of language feature, or an attribute, called overload resolution priority. So in this case here, I can simply add an overload resolution priority attribute and say which one takes the highest priority. If you're building APIs or big internal libraries, this is a good addition. Because you won't know if that there's an ambiguity until someone actually uses the code. And again, the new lock object provides a better thread synchronization through a new API. They're also making changes to how partial types work. So in C# 13, you can now have partial properties. And going forward, they're going to do even more with partials. And this is, of course, for source generation. If you're not doing source generation, like, there's no reason why you would add a partial class yourself and also the partial implementation in the same project. The final feature of C# 13 is implicit index access. If you're creating an instance of an object and you want to reference the last element, use the hat symbol, and that's implicitly then referring to the last element of that list on that type. Kind of a small feature to add as well. All right, so with a couple of minutes left, what's next for C#? There's quite a lot in terms of what they're experimenting with, and a couple of the things I'm going to show you probably won't make it, so it's just a little bit of fun. And I do want to say that they're doing an experiment where they're changing how async and await works. They're introducing a feature called, I think it's called async 2 or runtime async, depends on which week you're asking them. Basically, instead of requiring the compiler to do an implementation of a state machine and produce all the code that it has to do when you're adding async and await, what if the runtime knew about async and await? What about if it knew about green threads or better reusability of threads? If it did, then the compiler could just stop generating all that code for you, and the implementation of async and await would probably be a lot more performant. Because honestly, there's a lot happening when you're adding the async and await keywords. So that's going to be an interesting evolution, but probably won't make it to C# 14. Maybe it'll make it to, I don't know, 16, 17, who knows. Gives me a reason to come back. So for C# 14, there's a field keyword that's no longer a preview feature. There's implicit span conversion, so it's easier for you to use spans everywhere. It will just do implicit conversions wherever possible. There's this thing called extension members or extension everything. There's simple lambda parameters with modifiers. Again, partial improvements, so you can now declare the constructor as being partial or events as being partial. And again, this is for source generation, to allow source generators to produce code that's more performant or do whatever it wants, basically. There's also the null conditional assignment, which is, again, building upon this feature that's now, with this version, has been around for 6 versions of C#. Nullable reference types has been around for a long time, and they still find ways to improve this language feature. All right, so extension everything was supposed to make it to C# 13. In fact, it was supposed to be added a long time ago, but it's a really difficult language feature to implement. This is a public static class, just like you do any extensions. But instead of creating that extension method that you've seen in the past, we simply say, hey, this is an extension for the class user. And it's actually an extension on the instance of that user. So I can add instance properties or instance methods on it. So it's not static anymore. A little bit of a different way of working with the extensions. So basically, you can add whatever you want to any type available. The null conditional assignment will now, what this does is that it will first perform the null check before it sets the name to Filip. So instead of wrapping this in an if block, we can now very easily write this piece of code instead. I have a hate-love relationship with this language feature because I think it looks nice, I like the idea, but it will also be a lot harder to analyze visually the code that we look at. Like, again, not just because it's a question mark, but it's very easy to miss that there's a question mark here. It performs a null check. So therefore, it might not be set to whatever I'm looking at. I'm just thinking that this here will give me a little bit of headache when I debug my applications because I was scanning my code visually so fast. But we'll see. I like the additions and improvements in terms of null reference exceptions and null reference types, basically. So with that being said, there's a lot happening with C# as a programming language. We're going to see a lot of additions to C# going forward. A lot of this is going to improve the way that we work with C# and how we write code that's more maintainable and easier to understand and, avoid problems. Hopefully, you found some of these language features interesting and found some inspiration as to what you can add to your projects. And if you haven't, there's a lot of stuff I have on Pluralsight that you can check out. I have a lot of courses on C#, on building an operating system, if you want to do that, and going in deeper on async and await and all of that. Again, it was really nice talking to all of you about all of the new things in C#. If you do have any questions, send me an email afterwards. I hope you're going to try to apply some of this in your applications. And on the way out, feel free to leave a green thing in the box. If you didn't like this, skip the line and get a coffee. All right? Thank you so much.